Okay, today we're going to talk about chapter 11.3, which is acceleration. So you've all heard the word acceleration, and usually when people hear the word accelerate, they think of something speeding up. But acceleration is much more than that. It's actually defined as a change in velocity. So it is a change in speed, a change in direction, or both. And it's a vector, so it not only has a number associated with it, it also has a direction. So an example of acceleration that we deal with every day is freefall. So let's say that I accidentally drop the marker when I'm up at the whiteboard, which happens all the time. That dropped marker will speed up as it travels toward the ground because the force of gravity is pulling on it. And we call this accelerating toward the ground. So I would say that my marker is accelerating because its speed is changing. Its speed increases over time as it falls toward the ground. But acceleration isn't just speeding up. It could also be slowing down or changing direction. So free fall is an example of a change in speed. But a change in direction is also considered accelerating. So let's imagine that we go to a carnival and you sit on the merry-go-round. Once the merry-go-round gets up to speed and it's moving at a constant speed in a circle, you are considered accelerating because your direction of travel is constantly changing. In the first part, you may be traveling forward, but in the next part, you're traveling backward. Behind it, you're traveling to the back, and then when it comes around, you're traveling forward. So even though the speed does not change here, because the direction of travel changes, we consider that object accelerating. And acceleration can be speeding up, slowing down, or changing direction. But it doesn't always happen instantly. Sometimes we have a steady acceleration over a period of time, and this is what we call a constant acceleration. So, a constant acceleration would be coming to a stop at a stoplight. So most people, when they stop at a stoplight, will press on the brake and steadily come to a stop, and they slow down at a steady rate. That would be called a constant acceleration. You are constantly slowing down and changing your speed the same amount each second until you come to a stop. This would not be considered a constant acceleration. This would be considered an instantaneous acceleration, because rather than slowing down steadily over a period of time, this car is slowing down to a stop almost instantly. Now, really, it's not instantly. It doesn't happen in less than 0.0000001 seconds. It takes time to slow down, but we could still consider this an instant acceleration. It almost instantly comes to a stop. Now, because acceleration is speeding up, slowing down, or changing direction, we define it as a change in velocity. So if we put this into an equation, our acceleration is equal to velocity divided by time. And remember, I said acceleration is a vector, so it does have a direction. That means acceleration can be negative. So if you think about a number line here, and we define moving to the right as positive and moving to the left as negative, if an object moves forward this way, they have a positive velocity because they're moving in this direction. But if they're moving in this direction and slowing down, that means that their acceleration is acting in that direction because they are making their velocity smaller. You can think of it as a person walking and they have a rubber band tied around their waist. If they're walking in the positive direction but slowing down, you can think of that as being like being pulled backwards with that rubber band. So whichever way that rubber band, that imaginary rubber band is pulling, that's the direction of our acceleration. Now, if my person, instead of walking forward and slowing down, walks backwards this way, they have a negative velocity. And let's say the rubber band is still pulling them in this direction, they're going to end up speeding up. You can think of it as this rope going whoop and pulling them this way. So acceleration can be negative, but that doesn't always mean it's a deceleration. We're going to talk more about this in class, so if it doesn't totally make sense right now, that's okay. Just remember in your mind, acceleration can be negative, and all that's telling us is it's moving in a negative direction. Now, just like the slope of a position versus time graph being the velocity, the slope of a velocity versus time graph is acceleration. And we're going to take a look at what this looks like based on this position versus time graph. So remember, when we analyze the slope of a graph, we have to look at three things. Where does it start? Is the slope constant or changing? And is it positive or negative? So it starts at the origin, so that's where we're going to start down here. It has a positive slope because it's sloping upward. And if you look at it, it goes from a low slope to a steeper slope to a much steeper slope. So the slope is increasing over time. So since our slope is positive, it's going to be on this half of our velocity versus time graph. And because it's increasing, it's becoming more steady, my velocity versus time graph is going to look like that. The slope of this line is increasing in a positive way. Now, let's do the same analysis for velocity versus time to acceleration versus time. This slope is positive, it is going upward, but it's not changing, it's very steady. So, if it is an upward slope, it's positive, we're going to draw it on this half of our graph. And if it's not changing, if it's steady, it's going to be a flat line. Just imagine that's flat. I'll try and do another one. There we go, that's a little better. It's going to be a flat line. So what these graphs are telling us are, this object starts off at the origin and walks away in a positive direction slowly, then speeds up, then speeds up, then speeds up, and ends up going really fast. So the velocity starts at 0, almost at rest, and then speeds up and speeds up and speeds up. The velocity steadily increases. This line tells us that the acceleration is the same the whole time. And what that means is they gain the same amount of velocity every second. So it could be that they gain 1 meter per second every second. So after 5 seconds, they would be going 5 meters per second faster than they were at the beginning. So here are your homework questions based on acceleration. Have them ready for tomorrow.